All right, welcome to The Explainer. Today we're going to dive into something you see every day but probably don't think much about, the cement mixer. But trust me, there's some seriously high-tech engineering going on under the hood to make these things smarter, quieter, and way, way more efficient. So, here's how we're going to break it all down. First up, we'll look at the big problem with these mixers. Then, we'll get into the smart architecture they came up with to solve it. After that, we'll check out the heart of the system, the motor and the controller. We'll even uncover the secret sauce that makes it all run smoothly. And, of course, we'll finish up by looking at how they made the whole thing incredibly safe.
Okay, first things first. Why on earth does a cement mixer need a big, high-tech makeover? I mean, it just mixes cement, right? Well, the reason is actually pretty surprising.
You see, we tend to think of these things as just trucks, but here's the twist. Their biggest job isn't driving around. Nope, it's what they do when they're parked. And that's where the real problem lies. They just sit there for hours, engine running, burning fuel, just to keep that big drum turning. And get this. This is the crazy part. A traditional mixer can waste anywhere from 30 to 50% of its fuel just sitting still. I mean, think about that. Half the fuel, just gone. It's unbelievably inefficient, not to mention all the pollution it creates. And for the companies that own these things, it's a massive, massive cost. So, that's the problem. How do you fix something so fundamentally inefficient? Well, the engineers had to go back to the drawing board and completely rethink how these trucks work. They realized they needed to break the link between the big diesel engine and the drum itself. And the solution they landed on is what's called a series hybrid architecture. Now, what does that mean? It means the diesel engine doesn't actually turn the wheels anymore. Instead, it acts like a smart power generator. It just runs when it needs to, and always at its most efficient speed, to create electricity for the electric motors that do all the work. And the key here is using something called a power takeoff, or PTO, to run an independent generator. This whole setup is brilliant because it's designed specifically to attack that idling problem we just talked about. It's the absolute best way to get full power from mixing while the truck is parked, all without wasting fuel by running that giant diesel engine. But, a clever design is one thing. You've got to have the right hardware to back it up. So now let's get into the heart of the system, the motor and the controller. This is where the really cool tech choices were made. Okay, for the motor that actually generates the power, the team went with a Permanent Magnet Synchronous Motor, a PMSM. And you can see right here why they did it. Just look at this chart. When it comes to things like power density and efficiency, it's just a clear winner. And that's absolutely crucial when you're trying to pack a ton of power into a really tight space. All right, so you've got this awesome motor. How do you control it? Well, they went with cutting-edge Silicon Carbide, or SiC, controllers instead of the older IGBT tech. And trust me, this is a total game changer. The jumping efficiency is just massive, especially for a machine that's got to run all day long. Plus, it runs cooler, which means the whole system can be more compact and way more reliable. And this graph right here, this is what you get when you make those smart choices. It shows you exactly what the system can do. It's got that huge initial kick of torque you need to get a heavy, sloshing drum of concrete started from a dead stop. And then it's got the steady, continuous power to just keep it mixing for hours on end. But here's the thing, raw power is kind of useless if it's not efficient, and that's what this efficiency map is all about. The whole goal of the control system is to keep the generator operating right in that high-efficiency sweet spot you see there. Staying in that zone is how you get those incredible fuel savings and put way less stress on the engine. And the number really speaks for itself, 96.5% peak efficiency. To put that in perspective, old-school hydraulic systems are lucky if they even break 80%. So this is just a monumental leap forward. It's a huge win. Okay, so we've got this powerful, efficient system, but here's a really tricky problem. How do you keep this super precise electric motor from getting shaken to pieces when it's literally bolted onto a big, rumbling diesel engine? This is where things get really clever. The answer is something called active damping. And the best way to think about it is like a pair of noise-canceling headphones, but for the powertrain. The controller is constantly listening to the vibrations from the engine, and then it actively creates an opposing force to smooth everything out. And you can see the results right here in this graph. Look at that choppy, jagged line coming from the engine. The system takes that mess and, in milliseconds, turns it into that beautiful, smooth line of power output. This isn't just a nice-to-have, it's absolutely critical. It protects all the mechanical parts, makes the whole truck more durable, and, as a bonus, makes it a lot quieter to be around.
All right, last but certainly not least, safety. I mean, none of this amazing tech matters one bit if the system isn't safe. We're talking about high voltages and incredibly powerful motors here, so safety has to be baked in from the very beginning. So the entire system was designed and built to meet a really tough standard called ISO 26262. Now, if that sounds familiar, it's because it's the exact same functional safety standard that's used for things like automatic braking and lane keep assist in the car you probably drive every day. What this means in practice is that you have to think about the absolute worst-case scenarios. What if the motor just starts spinning uncontrollably? What about the risk of a high-voltage shock? As you can see, both of those hazards are rated ASIL D, which is the highest risk level there is. That means the engineers had to build in multiple layers of redundant safety systems to make absolutely sure those things can never, ever happen.
So, let's wrap this all up. What did we see here? Well, it all started with identifying the real problem, all that wasted fuel from idling. From there, it was about making smart tech choices, like that high-efficiency PMSM motor and the SiC controller. Then, they added that brilliant innovation, active damping, to make it durable. And they wrapped it all up in a design that's safe from the ground up. It just goes to show you can completely reinvent a machine that most of us probably never give a second thought.
You know, this whole project is proof that electrification and smart systems aren't just for fancy electric cars. They can be applied to these tough industrial workhorses too. And that really leaves you with a big question. If this level of innovation can totally change the game for a cement mixer, what other essential machine is next?